topic for this video is water. The essential questions are: can you predict if something will be an electrolyte? And what is the difference between a weak electrolyte and a strong electrolyte? So to figure out if a solution is going to conduct, you're going to see if it's an electrolyte. Okay, and an electrolyte is a compound that dissociates into ions, and dissociates means it breaks apart. And then those ions will conduct electricity. You can see in the picture on the right there, they're putting the wire into the solution and it's lighting up the light bulb. In order to be an electrolyte, first of all, they have to be able to dissolve in water, so that they have to be soluble. And then, so we know solubility, they could either be ionic and acid or a polar covalent compound, but the only ones that break apart into ions are ionic compounds and acids. So those are the only ones that are electrolytes. For example, copper sulfate, copper's a metal, sulfate's a nonmetal, so we know that's ionic, and nitric acid. A non-electrolyte doesn't dissociate, so it doesn't break apart, and then because it doesn't do that, it won't conduct. So covalent compounds that are not acids are non-electrolytes. Okay, so these are things that dissolve but won't conduct electricity. So like a sugar or an alcohol. Okay, so we're going to practice determining this. Again, if they don't dissolve at all, they can't be electrolytes. So we're going to look at the compound, determine the formula, classify as soluble or insoluble, and then decide if it's an electrolyte or not. So acetic acid is HC2H3O2. That's acetate with hydrogen. That's soluble because it's an acid. It's an acid, so that also means it's an electrolyte. Calcium chloride, calcium is Ca and it's a +2, chlorine is -1, so that's CaCl2 after I cross over. And calcium's a metal, so this is ionic, which makes it a soluble compound, and it's ionic, so that means it's also an electrolyte. Benzene is C6H6, so this would classify as an insoluble, and if it's insoluble, it cannot be an electrolyte. Okay, so we're going to look at whether something is a strong or weak electrolyte. So a strong electrolyte dissociates completely, which means that all the parts of the molecules break apart. Okay, so for, examples of things that do this are ionic compounds and strong acids. And there are 6 strong acids, and honestly, you're just going to have to memorize these. You have hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, and perchloric acid. And if you look at the picture on the top left where it says strong, you can see they've all broken apart into positive and negative ions. That's what dissociate completely means. A weak electrolyte dissociates partially, so a few of them break off and a few of them stick together. So if you look at the middle beaker on that top picture, the weak has a few pluses and minuses and a few that are still stuck together. This would be weak acids. So you don't have to memorize weak acids. You know your 6 strong ones, and anything else that's an acid will be considered a weak acid, and therefore a weak electrolyte. A non-electrolyte, first of all, things that don't dissolve, but if it does dissolve, it doesn't break apart at all. And you can see the beaker on the right, they are all still bonded together. So, like dissolves like. What does that mean? Basically, it's going to tell you that polar is going to mix with other polar molecules, while nonpolar mix with nonpolar. So, for example, oil is nonpolar, water is polar, so they can dissolve different types of substances. If something is miscible, it means 2 liquids that mix. I kind of remember that it's miscible, kind of sounds the same. For example, water and alcohol can be mixed. Immiscible, which means they cannot mix, would be like water and oil. Those separate out, like the diagram showing you there. So, what types of compounds are going to dissolve in water? We already said water is polar, so it's going to do that. It's also going to do ionic. Salt was the example we used, and salt is an ion. So it's with a metal with a nonmetal. So if you see something with a metal with a nonmetal, that's going to dissolve in water. For example, salt, potassium iodide. Acids, remember we identify acids as being a hydrogen with an anion. So HCl is hydrochloric acid, H2SO4 is sulfuric acid. So they start off with an H. If they're polar, we said like dissolves like, so polar dissolves polar. That's also going to be true. Some examples of that are hydrogen peroxide and ammonia. And any compounds with OH groups at the end, like sugars and alcohols, those are also going to dissolve in water. For instance, ethanol is C2H5OH, so we see that OH group that will dissolve. And glucose, C6H12O6, is a sugar, and that will dissolve as well. Things that don't dissolve in water are nonpolar covalent compounds, like hydrocarbons. So if they just have C's and H's, no oxygens, they're not going to dissolve in water. Okay, those are things like different types of oils. Also symmetrical molecules, they don't like to pull apart very easily, so like carbon tetrachloride. Silver nitrate was AgNO3. Silver is a metal, which makes it ionic. Okay, so ionic is going to be soluble. It's going to be an electrolyte, and ionic is going to be a strong electrolyte. So I put an S there at the end. Acetic acid is HC2H3O2. Okay, it's an acid. Okay, and it's not one of the 6 that I need to remember. And so it is soluble, and it is an electrolyte, but it's going to be a weak one. Hydrochloric acid is HCl. We know that's an acid, and that's one of the 6 strong ones. So it's going to be soluble, it's going to be an electrolyte, and it's going to be strong. Potassium iodide is Ki. Okay, that's a metal with a nonmetal, so that's going to be ionic, and that's going to be soluble, an electrolyte, and strong. Hexane is C6H14. Okay, so that is a nonpolar compound, and so that's insoluble, which means it has to be a non-electrolyte.